Hey everybody, welcome to the stream. I'm gonna get started. So what I'm gonna be doing today is I have a particle system that I'm running on the GPU using compute shaders, and right now it's just 2D. I'm gonna be adding perspective projection to it, so it's 3D. I'm gonna be adding some effects like motion blur and depth of field, and then I'll see how long it takes to do those, and then I have a few other things I might try. Like I might try doing some octree optimizations to speed it up, or I might try some different behaviors like flocking behavior instead of gravity. But anyway, so for anybody who didn't see the last 2 weeks, what I have right here is it's a Rust program using OpenGL. And I have two compute shaders and then a regular vertex and fragment shader going on. And so what happens is when I run my program, we have every one of these particles. Hey Riz. So every one of these particles has a position and a velocity and a buffer. So I'm running one compute shader every frame to update their positions, and then I'm running a second compute shader to draw them into a screen size texture, and then finally I'm drawing that to screen using a regular rectangle made of two triangles. So the first thing I want to do is, so right now my buffers for the particle positions and velocities are in 2 dimensions, so they're just moving in the plane of the screen. So the first thing I'm going to do is update these to be vec3s instead, so that they have a z position. And for now, I'm just going to ignore the z when drawing, which is effectively an orthographic projection. I'm just going to draw using the x and y. And then, but I'll be updating the positions in 3D, and then after that is working, I'm going to set up an actual perspective projection. So, if I'm updating my particles, positions, velocities to vec3s, I need to do that everywhere. I need to update my length code here to include the z as well. So this code is it's just basically doing a loop for every other particle. It is computing the distance and direction to that other particle, and then applying a inverse distance based attractive force. The inverse distance force looked a lot better in 2D, but I think that an actual inverse squared force will probably look better in 3D, so I'm going to change it right now so that it's so I take my length squared and so that's my inverse squared scaling, and then I also have to divide the direction vector by the actual distance, so that's the square root of my length squared. So hey Swan, welcome to the stream. Okay, so I think I've updated all of my update compute shader, the one that moves the particles, to be for 3 dimensions. So the next thing I'm going to do is do the same for my compute shader that actually draws the particles. So for now, what I can just do is keep this the same, but only grab the x and y values of my positions. So I'm just basically drawing it as usual, but then I have 3D positions. So I've updated my shaders. The fragment shader can stay the same. And now I need to update where I'm actually initializing the buffer. So last week I set it up so that I have 2 particle buffers, basically double buffering them, one every other frame. So like that lets me write to one of the buffers without synchronization while reading from arbitrary positions in the other buffer. And it's just the thing to do that makes sense because I want every particle's position on a current frame to be updated based on the total state of the world in the last frame. I don't want to be like updating some particles and then using their new positions to update others. It just doesn't make sense. So I'm generating a buffer, and I think my particles array it has 4 4 floats for every particle. So now it's going to be 6 because I have two 3D vectors. And let me just add a random z in here too. And I'm just going to spawn in a sphere centered at the center of the screen rather than a circle as it is now. And then I have to initialize. This is a hard question. So right now I'm initializing the velocities in kind of like a counterclockwise rotational direction. I guess I can just do that still and then have have my z value be z velocity be 0. And then it'll just it'll be rotating in the plane of the screen, but the particles will be getting forces along the z-axis, so it won't stay that way for long. And then I need to update the z position. And let's make sure I have my indices right. So these 2's should become 3's because basically I have every particle now takes up 3 spots in its position vector and its velocity vector. So yeah, 3 times num particles plus I. Yeah, I think I have my indices right. So the buffers are big enough, and I'm creating z coordinates and putting them in the buffer. Let me double check if there's anything else I need to change, but I think actually beyond this it's all correct. Okay. So I think I did something wrong because these particles up in the corner are weird. There's a lot of them clustered up there, so I might be doing something wrong. And then obviously they're not moving like they were before, so it's pretty strange. So let me take another look. X squared plus y squared plus z squared is my squared length of the distance vector between 2 particles. I'm applying an attractive force based on this vector normalized divided by r squared. So what I'm assuming with the corner particles is that I'm just initializing things wrong. So let me take a look at the initialization code again. think my indices are correct. Because, yeah, z is not affecting where they're being drawn. So I'm messing up what x and y values I'm getting. These are correct. Maybe I need to, that shouldn't change anything because I'm not drawing based on the z at all. Okay, let me look at this again. So yeah, there's two main problems. One is that it does not look like they're being spawned in a sphere at all. Okay, there's three main problems. The gravity also doesn't seem to be applying correctly. And the initialization is happening wrong. So, alright, I definitely have the right number of floats in here because each particle has 6 values for it. I'm definitely getting my indices right because every vector has 3 components. And it honestly doesn't matter what I put in here because I'm not drawing based on it anyway. Let me try moving my update code to just moving in the xy plane again. So x squared plus y squared let me just disable updating entirely for now and see how it gets initialized. I turned off velocity and it's still moving? No, I didn't turn off velocity. I turned off acceleration. Let me just turn off velocity updates position updates entirely. So yeah, here's my initial position. I'm going to debug this first and then I can get to the actual velocity problems. So I'm grabbing my position based on my thread ID, which there should be 4096 of. I'm not caring about my velocities. Try setting z to just 0, like with the velocity. Okay, so that is actually messing it up somehow. Probably a problem with Stride, actually. It's probably, my indices are probably not correct. So z does that when I set it to not be 0. Oh, I never noticed this. They're all along the top row and left row. That's kind of interesting. So is there anything in my draw shader that is messing up the 3-dimensional format? I'm only accessing the x and y of the positions. Okay, I'm a little bit stumped. 10 minutes into the stream. We can figure it out. Okay, let's do something simpler. If we just set all of the particle positions equal to 0, is there something that I'm doing wrong with how I read them out in the shaders? Yeah, so like particle positions being 0 is not working because the values are... So I assume it's reading the velocities or something? If I set all the velocities to 0 also, I'm betting that we'll actually put them on the corner. Yeah, so somehow it's reading velocities out of here. Am I declaring my... I can't imagine that this is the problem, the shader storage block binding stuff. Like, I'm not even giving this the sizes of these, so I can't imagine that's what's affecting it. So it's in the upper left. So that means, and if update is doing nothing, you know what, let me comment out all of the update. And then, so now we just have the draw. The draw is fetching zeros. If I change the velocities values to be 50 instead, how many particles get moved? None of them. So apparently it's not reading from the velocities. Let me see if I change my positions to 50. Well, it didn't move them by 50 pixels. It moved some of them by like 5 pixels. Very confusing. So I'm uploading it. I'm just giving it the length, which is, as long as I have this 6 here, I'm sure the length is fine. If I change the z value, does it change the drawn x and y values? It does. So yeah, I'm sure it's a format problem with the buffers. Okay, it's time to read a little bit more about the way that the buffer formats work. So yeah, when I'm dispatching the first shader, I'm doing shader storage block binding. So I need to look up how shader storage blocks work so that I can make sure I'm not doing something dumb. So shader storage blocks. I don't know if you can hear my dog barking in the other room. So binding equals 0. I am binding it to 0.0. Okay, I'm going to look up the function shader-short's block binding, see if there's anything interesting. So binding 0.0, that makes sense. And then the block index is from Git program resource index. Yeah. Alright, I'm going to figure this out. Khronos Wiki, shader-short's block binding. There might be some kind of alignment thing. See if this is relevant. So vec3s and vec2s get a vec4 slot. Why was this not explained in the documentation anywhere? Yeah, there's just nothing mentioning it. I guess I'm going to look at the actual standard. This is the Vulkan standard. I want the OpenGL standard. Okay, OpenGL. I'm just going to literally look at the OpenGL standard. Okay, so we're looking for the alignment of a shader storage block binding. Align searching for the word align in the OpenGL spec. Shader storage, double shader storage blocks. Yeah, if only all the data on the GPU were just stored in garbage collected hash tables, then life would be easy. Shader objects, buffer objects. Welcome to the chat, by the way, Charlie. Textures and samplers, frame buffers, vertices, vertex processing, fixed function. Going back up. Shader buffer. This is where I was. Offsets will be assigned using the method described in section 7.6, standard uniform block layout. When using SCD-140, structures will be laid out in buffer storage in monotonically increasing order based on location, base offset, and base alignment. The base offset of the first member is taken from the aligned offset of the structure itself. If the member is a 2 or 4 component vector with components consuming n basic machine units, the base alignment is 2n or 4n. Yeah, okay, so it's just 3 component vectors are aligned at 4n. I think that, I'm not 100% sure if that means that there's padding between these two arrays, or there's padding. I kind of doubt that there's padding between every element of this array. Yeah, it's nice to actually have the info you need. I should have started looking things up in the OpenGL spec earlier in my life, I think. Oh yeah, this is actually what I needed. If it's an array of vectors, the base alignment and array stride are set to match the base alignment of a single array element. So I guess the array padding actually should be 4. I mean, the array alignment should be 4. So yeah, I'm assuming that just every vec3 in the array is taking up the space of a vec4. So let me just change this 6 up here to an 8, and then change this 3 to a 4. And that probably should be it. Well, they're all at 0, but that's how it was before. So let me go back to spawning them randomly. 18 different several hundred page PDFs. Sounds kind of terrifying, but if you're actually working with it, it's probably cozy. Anyway, this is what we wanted, so finally it's working how we wanted. GlowCoil discovers shader storage buffer object alignment properties. Well, I guess I'll know about that going forward. Anyway. It's interesting because I think every type of buffer has a whole different set of alignment requirements in OpenGL. Like, whether it's a vertex buffer, things are basically optimized for type packing, so you can, like, basically you don't ever need padding. Everything is as tightly packed as possible, even if it's like totally heterogeneous elements, like you have a vec4, vec3, and then a byte, and it will pack them all tightly in bytes. And then textures, on the other hand, they have to be like more regular than that, but you can have a 3-component texture without padding between the elements. It's still tightly packed. So I guess my intuition coming from those just didn't transfer. Like uniform buffer objects, I'm sure work the same way as this. I think that section in the spec was about how both work. Anyway, just gonna make sure I didn't mess anything up by initializing velocity. But of course, update is turned off, so now let me see what it looks like when things are updated. Well, things are not being updated. because I still haven't printed out. Okay, here we go. Not what I expected. Maybe I need stronger gravitational constant. So let me just multiply gravity by 10 and see what happens. This is really weird though. Like, it doesn't at all behave. Okay, now it's behaving kind of how I expected. Some stuff breaks away, some stuff kind of falls into clusters like before. It's interesting though. I'm sure this is more like actual gravity than it was. Let me up the simulation speed so we can see what's happening better. Another thing that's probably relevant is that I'm doing Euler integration, so like there might be a better way to preserve the properties that I want. Like if you'll notice, I'm turning down the simulation speed by 90%. Like this is 1/10 the simulation speed, and it behaves very differently. Like it's slowly settling down. Whereas if I increase the simulation speed by a factor of 10, everything just zooms out. So I'm gonna try turning down the initial velocity they give everything, because divided by 10, because I'm sure it makes it weird to give everything such a high like initial kinetic energy. Anyway, yeah, I still don't know if this is what it's supposed to look like. I don't consider it as pretty as last time. Let me just add in adaptive substepping in GPU sims. I'm sure that people do when they're doing GPU physics. Like maybe not super important for particle systems, but for like, I don't know, rigid body stuff maybe, or like if you're doing deformable stuff on the GPU, I feel like people probably do use more sophisticated updates. I don't remember any specific examples that are coming to mind, but I'm sure people do. In any case, I should probably just fix this so that it's relay at least for now. I'm going to see what happens when I do just inverse distance rather than inverse squared. Okay, that's too fast to see. Slow it down. Screen record one overnight at 10,000th the speed and then speed it back up. Yeah, I guess I should do that. Or I could use an integration method with a faster convergence and then use a small fraction of the time. Anyway, this looks pretty cool. So I guess my opinion is that inverse distance in all dimensions just looks cooler. Oh yeah, and then let's try it with friction. It really just settles into a central blob like right away. Anyway, I'm not going to dwell on this too much because I'm not married to the gravitational thing. Like last time I wanted to try Boyd's, so I might try that eventually. But as long as it's working in 3D, I want to be able to. The things I want to do today are I want to be able to rotate the camera, maybe zoom. I want to have a perspective projection, and I want to do depth of field motion blur. So now that I have things in 3D, I think the first thing I'm going to do is perspective projection. So that should happen when I draw. I'm not going to bother yet with like a full-on camera transform matrix. I'm just going to just do like a naive like Z divide, which means I need to get my I need to get my coordinates into like clip space or whatever so that I can divide by z. So right now my positions are in like pixel units. So I can just make my z. No, the z needs to be in the same units for iteration. But then I can just let me just divide z by 1,000 for now, I guess. Well, okay, let's just start by dividing by z and see what happens. So in my draw shader, I get my position, and then I'm just gonna say the important thing is I do need to have it centered. So like center of the screen. What is my resolution? My resolution right now is 1600 by 900, so center of the screen is just going to be 800, 450. Really should eventually stop hard coding literally everything, but and then let's re-add the center because I'm drawing them in pixel space. So I'm centering them at the center of the screen, dividing by z, and then re-adding center. So let's see how drastically this messes everything up. And let me try multiplying z by like 1,000 and see if we get like really extreme perspective. Maybe I need to have camera rotation so I can actually tell, because it's pretty hard to tell if I'm doing this properly or not. Let's just make it have like a very high z range. Yeah, there's no way I'm going to be able to tell unless I actually do rotation, I think. So I'm doing z divide right now. Don't know if it's doing anything. And then, oh, another thing is z should be positive. And right now z is positive. Okay. So okay, I'm going to leave it like this, and then I'm going to set up a camera rotation. So that means I need to have a matrix for my camera. And then I need to take some mouse input. I'm going to copy paste this out of another code base that I have. So copy pasting my matrix class. And then I will use this. See if that compiles. I need to copy in my vector type as well because it refers to it a lot. Let's just call the file geom. Use geom at 4x4 vec3. Rename this. Okay, I'm just gonna copy paste the whole file. So I missed a couple of things. Okay, we're good. So now I'm gonna copy paste my camera rotation code. So I have my cursor position, whether I'm dragging state, and my rotation matrix state. There's a z value also. I'll handle that later, that's for zooming. So let me copy in my mouse event handling to window event, mouse wheel. Let me pull in vec2. And then they changed the API. So let me go look up at the gluten docs again. Changed it since I last used it. Let's go to window event. So the mouse input event has a button, which is a mouse button, which is in gluten event mouse button. Gonna assume these are also just in the event module. Okay, so now we are rotating, but it's not actually using it. So I'm gonna need a uniform to feed this 4x4 matrix to the draw shader. So where I set up my draw shader, I'm gonna say glget uniform location. It'll be okay, so draw will take a 4x4 matrix. So it's hey Zianic, welcome to the stream. I'll see if I can get the face of God to emerge from the particles. I'm not sure if it'll happen this week. But hopefully soon. Okay, so it's M4 UIV. Let me matrix 4 FV, that's what it is. Uniform matrix 4 FV transform, and then this is taking takes location, count, transpose value. Let's make sure I'm not missing something. So yeah, I think so it should be 1 because I just have only one matrix. Transpose is because I think GL is column major. And I think that I'm gonna see how I did it in that other code base. So somewhere in my renderer. I am transposing it because my matrix is row major and OpenGL's is column major. So get uniform location transform. Transpose true. Count 1. And then I give it 4 FV gets just a pointer to the values. So in my case, I just take the matrix dot 0 as a pointer. What did I call it? Called it rotate. So let's rotate dot 0 as pointer. Let's see if that compiles. Okay, so it's fine with that. So I'm feeding it the uniform now. It's not using it yet. So let's see what happens if we try to use it. So I'm just going to multiply positions by it. I'm not going to try. I should comment on the z divide and just. Oh, yeah. Oh, you know what? I made a big mistake earlier and I never even used the z divided version. So before I even try this, I should try that again. Implicit cast from vec 4 to vec 3. Where's that happening? Line 18. Implicit cast from vec 3 to vec 2. Yeah, so it should be vec 2. Yeah, one more place to change it. Well, we're definitely z dividing now. So let me divide by a smaller z. That definitely looks right. I can't believe I was just failing to do it before. It's not really visible now. But yeah, it's definitely visible there. Okay. So I'm going to comment down my z divide. And I'm going to multiply by the transform and see what goes wrong. It's a typo. Okay, so let's see what happens when I drag my mouse. Hey, we got camera motion. Of course, it's rotating around the origin, which is not the center of the particles, which is what I wanted. So maybe I should just change my entire particle coordinate space to be centered at the origin. And then, like, eventually I should set up a proper camera matrix for this. But for now, I'm just going to say particles are centered at the origin. So I'm no longer offsetting the particles. We have an 800 radius sphere for the particles. They should be in the upper left corner now, I think. They are not. Positions are centered at 0, 0, 0. And then I'm just going to say they get added to center. It's a bit confusing. Oh yeah, I need to change all of these because now they're centered at 0, so I don't need to... The problem here was my rejection sampling was selecting for a... Now it's only in one of the quadrants or octants of the circle, of the sphere, I mean. So yeah, now I am... Oh yeah, these are still positive, so I need to just center these at 0. Oh yeah, and I forgot to do it here as well. Okay, so this should be centered. And that's closer to what I wanted. So the X, Y, and Z are centered around 0, 0, 0. The camera rotation matrix is just by default rotating everything around the origin. I think, yeah, okay, so I think it's actually working properly, but the thing is, I don't have any like near or far plane clipping right now, so no matter how far something is behind me, it still gets drawn on the screen and looks like it's in front of me. Also, it's back to being orthographic. So if I actually do Z divide, well, that does look really cool. I think what I need is to do Z divide and then move everything further away from me. We'll do that before the Z divide. So yeah, just right now Z0 is at the camera. So I'm gonna make it so that, yeah, I just need to add to this. So Z plus, let's just say 800. I feel like something's wrong because the center's not at the center of the screen. But yeah, I'm just offsetting it by, well yeah, this is the center of the screen. So I don't know why it's like off, but it still looks good, I think. Looks pretty cool. do want to figure out why exactly it's a little bit messed up. And I mean, there's no requirement that this be the actual center, that the like cluster that it settles onto be the actual center of the screen. But there's something weird going on, I think. Anyway, this is, I assume this is what gravity does. I don't know. Maybe if let me turn the gravitational constant way up. And then let me try turning it way down again. Oh yeah, plus I have my friction on. I'm just going to turn friction off and see what it looks like again. That was pretty nice. Let me turn up simulation speed. Oh, you know what? My velocities are weird. Like, my velocities are not... Yeah, I need to just kill this offset on the velocities. I think that's probably everything that's making it not be centered. So weird. I don't know what's going on. I mean, it's still pretty. Turn up the gravity again. That's starting to look more like what I would want it to. And I do think that I should just introduce some near plane clipping. Like, I'm just going to say if z is less than 0, or I guess less than negative 800 in this case, yeah. I'm only going to draw it if it's further out, because it's probably confusing me to have particles behind me being drawn still to the screen. So now if they go behind me, they disappear, which I think is less confusing now. Wow, it really just blows up if things are too fast. Okay, so one last thing, I want to figure out why it's not centered properly, and then I can move on to doing motion blur. So I'm doing my z divide, and then I'm offsetting it by 800 and 450. My window size is 1600 and 900. And is my buffer size also 1600 and 900? Or where am I allocating my buffer? So it is. So 800, 450 should be the center. Let me just do something dumb. So that is the center. So, oh yeah, I keep just not changing stuff in every place when I need to. Now I need to add center. Here we finally go. So here we have our centered particle system that we can rotate. This is what I wanted it to look like. It looks pretty cool. So now that I've done 3D and perspective projection, the Boyds are indeed back in town. So the next thing I'm going to do is motion blur. So conceptually, what I'm doing right now is each particle is just at a point, and I'm thinking of them as just, I'm drawing them in screen space so they don't actually shrink as they go further away. They're just like a single 1 pixel diameter point. So I'm doing a little bit of anti-aliasing where I find the 4 pixel quadrant that they're in, and then I put alpha values in those 4 pixels based on the position of the point. Bust out my magnifier. You can see that these take up like 2, 3, or 4 pixels at a time, with a nice little fall off around where they are, so that gives you some anti-aliasing. So motion blur is also a type of anti-aliasing, but it's based on, so right now I'm drawing these particles as if I have an infinitely fast shutter speed, as if I'm taking a photograph of the particles, and the positions of the particles are static for the length of time that I'm taking the photo. So the only anti-aliasing I'm doing is over the particle footprint over multiple pixels. So if I want to do motion blur, conceptually what that is imagine that my camera shutter is open for a finite amount of time, and every pixel is moving during that time. So the faster the pixel is moving, the longer of kind of a smear I will receive. I will receive photons from that particle. So in this case, I do have my positions and my velocities fed into the draw shader. So what I need to do is, based on velocity, I need to smear the particle. And I'm making things pretty easy on myself because this renderer is purely additive. It's just every particle is the same color, and I can just atomically add values into a texture for where each particle is. If I had particles of different colors and things in front of things occluding them so that that surfaces could hide other surfaces, then I would have to do things a harder way. And this naive motion blur algorithm I'm about to write would not look correct. So as an example, suppose that I have both my hands up here in front of the camera, and the hands are moving very quickly. So like during one shutter opening, my hands move across the full camera. If I just drew my hand, my front hand and my back hand at like 50% opacity in a smear, you would see at every point both hands translucent in front of me, and you'd see my shirt behind them. But the correct way to draw that would be, at every point in time in the frame, this hand is occluding this hand, so you should not see this hand at all. So in correct, if I'm actually solving the hidden surface problem and doing motion blur, then my back hand should not show up at all in the blur, and only the front hand should. Whereas in my naive thing I'm about to write, I'm drawing both. It doesn't really matter because I'm doing things additively. So basically it's like each particle is a transparent glowing dot. Eventually I'll have to do it a harder way, but this way I can just like, I can draw a trail as long as I want. Semi-transparent geometry that properly represents motion blur. You can do it for an individual surface, but if you're drawing them alpha blended, like I just explained, yeah. So if it's semi-transparent geometry and you're drawing it alpha blended, back to front, then there's no way to do it properly taking into account occlusion. Like, I think it would look bad pretty quickly. Like, suppose you rotate the camera quickly so everything gets motion blurred. You would become a wall hacker, because if you draw all of the walls semi-transparently, smeared across their motion blur footprint, then you can see through all of the walls to each other. So in some limited cases, suppose you were doing this particle system that I'm doing, like kind of superimposed on top of another scene, you could draw the particles themselves transparently for motion blur. But if you have inter-occluding surfaces, it's harder to solve it. Similarly, it's harder to solve just anti-aliasing in general with occluding surfaces. Like right now, I'm just looping over my whole pixel footprint, going to 4 different pixels that could be part of my particle, and adding my contribution. If the particle got bigger, I could just loop over a bigger area of the screen. But on the other hand, if the particles block each other, I need... Oh, and the other thing is that I'm just adding float values, or they're actually int values, but I'm converting like float opacities to an integer from 0 to 255 right now. Okay, yeah. So in an offline render, we often cheat for volumes and small parts. Yeah, exactly. So like it works fine for like fire sparks or something, because effectively those don't really occlude each other either. They're mostly emissive objects and not really opaque. Yeah, if you could do it with general scenes, we probably would have seen like games trying to do it in 2005, you know, because there's a similar nowadays everybody does everything post-processing, and motion blur in post-processing is, while there's still artifacts, like for instance in my earlier example, suppose if instead of moving we rotate my hands, then on the frames where part of the motion blur process includes a hidden part of my hand, there's missing information. So post-process motion blur still has artifacts, but it doesn't make everything transparent, so it's much more acceptable artifacts. If you go back to the year 2005, everybody was doing like shadow volumes, which is where you take literally the mesh and turn it into a shadow mesh shape, or like expanding your mesh outlines to do like a black outline around your character. So everybody was doing mesh-based effects. So if motion blur with purely mesh-based effects were acceptable at all, people probably would have tried it back in like 2005 days. But yeah, like I explained, it just completely breaks occlusion, which is why you have to do some kind of multi-sampling solution, which nowadays people integrate it into their temporal anti-aliasing, which effectively is doing a multi-sampling solution for motion blur. Okay, so a GPU ray tracer right now, which can't do motion blur instance objects. Yeah, like you can basically hack it into, for things like Sparks, you can hack motion blur into an existing renderer that doesn't support it, but you basically have to do like what you would have to do is basically an accumulation buffer method where you re-render the scene multiple times at different time values, and then average them together, and that would basically be multi-sampling your motion blur. Anyway, so like this is similar to how my anti-aliasing, I can just add float values, so I get a very smooth fall off for everything because I have continuous float values for the opacities. Whereas if I were trying to solve occlusion properly and like having walls covering up other things, you can't just combine float value opacities, because you need to know which parts of a pixel are being overlapped by things. Like it matters if, like when you have a pixel that's halfway covered by an edge of a wall, you can't just blend it in with 50% opacity at everything behind it, because it covers half the things behind it, so those things should be mixed in at 0%. So that's why GPUs have support for multi-sampling, but they don't support like solving anti-aliasing on edges of meshes by drawing them with partial opacity, because it just has artifacts and is incorrect. And similarly, trying to do that with motion blur is incorrect. Anyway, so to go back to what I was about to do, sorry, my throat is kind of hoarse, I think probably just from talking, but I'm gonna grab a cough drop so I get better. Okay, so right now I have a fixed 2x2 pixel footprint for every particle, and for motion blur I need to expand that footprint and have some kind of for loop over possible positions. There's a name of a classic anti-alias line drawing algorithm. I forget what it's called. So the Bresenham algorithm is for non-anti-aliased. The Wu line algorithm is the one with anti-aliasing. I think what they do is they just loop along one axis, and then on the other axis they do the semi-transparent values from one edge to the other. So conceptually, my particles here are 1 pixel radius circles. I mean 1 pixel diameter circles. So if they get smeared along some line, then they become basically just a one pixel thick anti-alias line. So I can extend my current method, which is distance based. I basically just find a distance from the center of the circle, and that's my anti-aliasing value. And instead, if I just project it onto find the projected distance from that line, then I think I get the same thing. Basically, it's just like an anti-aliased capsule shape. I'm trying to think if this is going to extend to depth of field as well. Depth of field is basically a circular filter convolution. And so I'm trying to think. I think so basically because my anti-aliasing footprint of the line, let me open up an image editor and like kind of explain what I'm doing. So currently, if this is the pixel grid, yeah, so if this is the pixel grid, and I draw a circle which is 1 pixel in diameter, then it's going to be covering some combination of 4 pixels maximum. If I instead have let me draw a larger grid. If I instead extend that to some kind of smeared out capsule shape, so like if here's my start of my frame pixel, and then here's the end of my frame pixel, then connect these two, and I want to have some like slightly faded out. Do people bother with actually recording particle locations across frames? So it depends. In real time, like I was saying, nobody even does actual like people aren't doing actual particle motion blur that knows about the particles. They're doing motion blur as a post-processing effect on the full screen. And then they do have like a velocity buffer that basically says for every pixel, what is my velocity? So in that case, they are just going to do linear velocity extrapolation for where that pixel has been in the past shutter interval. I think that in offline expensive rendering for films, people also tend to just do linear velocity extrapolation, but I think it differs. I think some people get more hardcore with it and do actual multiple positions. And so like, for instance, you could have 3 or 4 positions in a frame and interpolate those. So like if a motion blur footprint, if an object is significantly curving in a frame, then you could interpolate those positions in the curve. And there's different renders definitely do it differently. Some of them probably just linearly extrapolate. And there might be settings for it. Okay, so Lewis says they do usually, but you can have acceleration blur, which is basically lets you have a parabola-shaped motion blur footprint in addition to just a line-shaped footprint. Anyway, I'm just going to do a line for now. So in this case, I have to loop over all of the pixels covered by this. I wanted to think through if depth of field can work here as well. So with depth of field, basically what that even means is in a camera, you have like the pinhole aperture that the image goes through. For character meshes, people use fully steps. Okay, that makes sense. Yeah, 8 steps per frame. So what depth of field actually is you have your lens and it focuses the image into an aperture. Light goes through the aperture, and then onto the sensors or the film. So the shape of the aperture is not infinitely small. So basically there are multiple, if you had an infinitely thin aperture, you'd have an infinitely sharp image perfectly in focus. But because it's basically like a circle, every image that could possibly go through every different point in that circle gets averaged together. And so basically it's a convolution with a circle based on how far away from the plane of focus you are. So in my case, since I'm kind of cheating with everything and I'm just splatting everything into a buffer, I think I can literally just enlarge the distance value. So like right now the distance value would be, here's my line from center to center. And my opacity will be 1 at the center, 0 on the edge, or no, 0.5 on the edge, and 0.5 past the edge. And I think that if I simply thicken it for depth of field, that should be, and correspondingly faded out so that it's not full opacity. But if I just thicken the filter footprint, so like if stuff is blurred to twice its size, it would look like this. And then the edges of my pixel footprint would end up looking like this. And then I would correspondingly fade it out, because basically the total brightness that should be contributed is like constant, no matter if it's spread across many pixels in a blur, spread across more pixels in a depth of field circle of confusion is what it's called, or all concentrated at one point. Okay, so I think I'm satisfied that I can do both motion blur and depth of field using this simple line distance framework. For anything more complicated, basically you have to resort to multi-sampling. And sometime I'm going to do that in, I don't know if I would call it this render or a future render I'm going to work on, but eventually I'm going to move on to rendering actual triangles, in which case I need to do proper multi-sampling. So I need to basically find a reasonably small conservative set of pixels to do a for loop over, and then compute the distance to the line. So let me think. I think the Wu's algorithm will tell me what the actual pixel footprint I need to consider is. I mean, this is just a dump of pseudocode though, so it's not very helpful to me. A lot of weird content farm websites have basic vector graphics tutorials. Yeah, this is kind of what I was thinking. Basically, you march along the longer axis of the line, and then you go down each perpendicular column of pixels for the appropriate width. So in my case, I need to... So what the line looks like is, I'm just going to say, what are my velocity ranges? So right now my velocity is just being added to the pixel position every frame, and it is in pixel units. Like, I have a one-to-one position to pixel mapping. If it were more complicated than that, I would have to put in some more uniforms to keep track of things, like how big a velocity is on screen. But basically, because I have an update speed of 1, the velocity literally is just a vector that tells me where I was a frame ago. Or you can also look at it as like my current point is halfway through the velocity vector. It's up to you really whether you consider your frame to be like at the end, beginning, or middle of the time interval. I think in post-processing temporal anti-aliasing integrated motion blur, they assume they're at the end because they're integrating it over multiple frames. So you only have access to the past, basically, is what I mean. Okay, so given my position and my velocity, I'm going to say that the line ends at current position and started at position minus velocity. So let me grab velocity first. Okay, so it's position minus velocity to position. I don't need it to be. Yeah, this should be after projection. Okay, so this does pose a difficulty. I have to transform my velocities as I transform my positions. Because when I rotate the camera, the velocity is in world space, and I need to figure out what it is in screen space. And because I think the easiest way for me to do this is just transform both my previous and my current position. So let's just say previous equals position minus velocities. And then we will transform the previous position the same way. I could probably save some work by not doing it that way, but I just want to do it a simple, dumb way to get it working. So let me extract this into a function. So project takes in a vec4, transform matrix, and a position vector in homogeneous coordinates, meaning it has 4 coordinates and the fourth one is a 1. And then what it does is you multiply and then divide by z. So right now, I only need it to be a 3 by 3 because I'm disregarding the fourth component. But eventually, if I were feeding in an actual perspective matrix instead of just a rotation matrix, I would be encoding the value to z divide by via that matrix, but for now I'm just kind of hard coding it in here. So I transform with the matrix, and then I do my z divide, so it's and then here's my z divide thing. So this is my code for actually drawing the pixels. This is my code for fetching the position in the previous position. And then I'm going to say my position is my project position plus the center of the screen. I'm not doing anything with previous yet. But let's make sure this still works. Cast from vec4 to vec3. Line 20. Yeah, okay. Too few parameters, that makes sense. Transform. I think I could just use it because it's a uniform. I don't think I need it to be an argument, but that's okay. Still works properly. So now I have my previous position and my current position. So that forms a little line segment on the screen. And I need a loop along the longer axis of the two. Although I don't think it would break if I did it along the shorter axis. Would it? I mean, the lazy thing is just to loop over the bounding box. So I'm just going to do the lazy thing for now. Because, so for some performance context, right now I'm taking like 5 milliseconds for my physics update, because I'm doing it in a very naive way where every particle loops over every other particle. But on the other hand, let me copy paste my timing code around my draw call. My draw shader call. So here's my dispatch compute. So every other value I'm printing out should be the time it takes to draw. And right now it's so puny, it's like 10 microseconds per frame to draw 4,000 particles. So like I could afford to be pretty much like 1,000 times more wasteful than I am, and I would still be real time. So that tells me I can be lazy for now, just loop over the entire bounding box of the line, and then for every point in there, compute my distance to the line. So yeah, I'm gonna do it that way. So my upper left right now is just 0.5 up and left. So what I'm doing is I'm taking the minimum x and y coordinates of my position of my previous position, and then I'm rounding them down to integers. And then what I'm going to do is max is I'm going to say floor. Well, okay, so I think I'm just going to add 0.5 or 1.0 1.0. So if I add 1 pixel down into the right and then cast it to an integer, that basically rounds it up. So now I can loop from min to max. I'm going to keep my near plane clipping in here. And then for now, I'm just going to, for every pixel in the bounding box, well, I'll see if it looks the same if I have the same distance computation. Maybe I made it. Okay, I think it's looping. There's probably an error in my looping code so that it's doing a ridiculous amount of looping sometimes. Yeah, because frame 1 it was 14 microseconds. Frame 2 it was 80 milliseconds. So yeah, something's wrong. If I'm only drawing to 1 pixel, this is what it looks like. Still getting these hitches. That's weird. Why would this? I'm immediately braking after the first. Oh, I'm not doing double brake. Yeah, so that makes sense. Here we go. This should never have hitches, and it doesn't, so we're fine. So my loop bounds are not correct. It's kind of hard to tell what they are. Taking my two positions. I mean, maybe, okay, let's just clamp previous. So I'm gonna say that what are my velocities? Yeah, okay, so it does make sense that it's hitching because velocities can be arbitrarily high. So maybe, okay, gotta make sure I don't hang my computer from infinite loops in a shader. Anyway, for now, I'm just gonna multiply velocities by 0.01. It's still hanging, well, it's still hitching really bad. It's weird because these timings are really short, but it's still doing that hitch. So I honestly don't know why it's behaving like this. Okay, it's got some long times, so that makes sense. Although those are still like very weirdly long hitches. So yeah, I think I should clamp velocity to just be maximum 2 pixels for now, just to make sure that it doesn't. Yeah, you're probably right. And I don't want to clamp my physics velocities, but I do want to clamp my motion blur velocities. So I'm gonna say max of velocity and -2, and then min of velocity and +2. And hopefully this just stops the hitches from happening. It has not stopped happening. Yeah, I'm getting these like really long frames, like 23 milliseconds. So maybe something's wrong with my for loop here. Yeah, I'm sure it's just something with the index computation here that I'm doing wrong. Anyway, I can change my coverage computation to be that line projected line distance rather than so currently we're taking distance from the particle x and y. Let's see if it blows up if I'm doing a 4x4 window instead. And yeah, that's not hitching either. That's still taking like 18 microseconds. So it's got to be like absolutely massive values for some reason that I wasn't catching. Okay. So this is my pixel center. So then I'm taking my distance between the pixel and the position of the particle, and then the distance of the previous one, and then I can take the projected distance to the line between them, which I will do basically with the cross product of the pixel position and that line. So I will take pixel minus pref2d cross and it's I've got to have it like normalized. So let's say normalize. So this is a normal vector along the velocity distance in screen space. And then, so now I can say pixel.x minus p2d.x times line.y minus pixel.y minus p2d.y minus line.x. So this is basically taking the 2D cross product, or the determinant, or whatever you want to call it, of the vector from the previous position to the pixel and the vector from the previous position to the current position of the particle. And so that's going to be positive on one side of the line, negative on the other. I don't care about this sign, so I can just do absolute value. But these are, so now I have distance to one point, distance to the other point, and finally distance to the line, and I just take the minimum of those three. So now my distance value is going to be min minimum of these three distances. And let's see how it looks. Can I call a non-functional? Oh, because min and max. Okay, so I need to name these something different. Probably top left and bottom right. Hey, so it's actually drawing these line segments. It's not doing it properly, but at least it's doing basically what I wanted. Okay, so they're all like the same length, which is not what I want. I want them to be, oh, they're all the same length because I have a fixed size window of 4. I don't think it's just min of the 3. Yeah, that's definitely not correct. I know Inigo Quiles has a distance to a line segment. If my brain were doing better right now, I would just think it through, but I'm just gonna look at these because he figured it out for me. So I think he has a 2D primitives one as well. 2D distance functions. So yeah, for a line segment, this is what I want as a distance function. So P is the point, and A and B are the endpoints. PA is P minus A, BA is B minus A. So that's similar to what I'm doing. And then it's clamp. But yeah, what he's not doing a cross product. He's doing a dot product with the line, clamping the dot product to 0 to 1. That makes a lot more sense. Finding the nearest point by basically projecting it onto this line, clamping the position along the line to 0 and 1, and then finding distance again to that point. So I was close, but I should have just done dot product. So I have so line is my BA equivalent. So I dot those two together. Then I divide it. If I have normalized the line, that's basically what he's doing already. So dot P against the line, and then I clamp that. So that's my T value, and then I'm going to do... Oh, you know what? I don't want line to be normalized. Because I use it again in a second. So this should actually have shorter lines. Like before it was infinitely long lines. Now I have only actually moving particles have lines. And you can kind of see it's working. Stationary particles are a single point. So I've really got to figure out why. Oh, also, this will be much harder. No, I don't think it'll be that hard, but I want to have motion blur when I rotate the camera too. Right now it's only taking into account the actual physical velocity. I think I just need to have a previous frame camera matrix as well, and then that will let me just multiply previous position by the different matrix. Yeah, so it's actually pretty straightforward. And I think that's going to look pretty cool. But first, before that, I should fix my indexing problem. I gotta go take care of something. Alright, hey guys, I'm back. So I'm really close to having this working. So we've got the actual distance anti-aliasing computation working. The problem is just that my pixel footprint for loop thing is somehow incorrect. So I'm taking the minimum and the maximum of my two positions. I'm just gonna comment at the actual drawing and try to just draw these two values, splat them into the buffer and see what is happening. So top left and bottom right. I'm just drawing a pixel into the top left and bottom right of those rectangles for each pixel. And it looks kind of cool. Let me make them less dim so that I can actually see them. Okay. All of them look very small, although I'm sure that it's like a couple of degenerate cases that are the problem. Although I think okay, I'm just gonna take off this plus 1 1 here. Okay, and let me see if the for loop blows everything up without that. I think it's not blowing it up now. I think it's fine. So yeah, and then one more thing is I need to enlarge that box by the radius. Oh, maybe that's true. Maybe I should just clip at the left and right top and bottom of the screen as well, so that if something is, that's actually a good idea. You're probably right. So this will only draw them on the screen. So it should at least go to some degree to help with that problem. Well, I should go based on my pixel footprint. So this will clip them to inside the screen. Swizzle mask not present in operand Z. Oh yeah, this should be position. Okay. So yeah, looks like we're not having problems anymore. And now what I'm going to do is, I'm going to try saying, so right now our radius is 0.5. So I'm going to enlarge the pixel footprint by enough to contain 0.5 pixels in every direction. And yeah, that's not blowing up at all. And everything's actually looking good. So let me enlarge everybody's velocity so that by 5 times, this will probably make it a lot slower, but the trails should be longer. I'm not sure why they're not. Oh, I'm still clamping. Okay, I'm going to stop clamping velocity. And see what happens. Okay, yeah, so those are already way longer. So I probably should be clamping velocity in general. But we're not going slowly right now. Yeah, it's still steady at like 20 microseconds. Yeah, thank you for pointing out. I should check chat more often. People find my stupid mistakes before I do. So yeah, this is looking like it's supposed to. And just for fun, I'm going to try enlarging the radius. So right now my radius is 0.75, yeah. I think that means the radius is half that. Let's make it up 1.0. Let's try making it 2.0. So the coverage is, it should be 0.5 when this pixel center is the full radius away. And it should be 0 when it's 2 radiuses away. So it should be, we have the distance. We should, distance divided by radius. And then distance is going to be at 2 times radius is, wait, so when the distance is equal to the radius, it's 0.5. So we need to divide it by 2 times radius, that's what it is, yeah. Yeah, okay. And then it's going to be 1.0 minus, yeah. Don't think I did that right. There are the hinges again. I think I probably was wrong in this divided by 0.5 radius. Okay, still have the problem of just absolutely massive pixel footprints. I think I do need a clamp velocity, but I don't need to clamp it at 2. Still don't know why it's blowing up like this. Oh, I'm multiplying it by 5 still. Okay. Clamping velocity at 4 pixels. Yeah, this is very frustrating. Yeah, no, clamping the bounding box is definitely what I should do also. I can just use clamp, yeah. So clamp. Yeah, like, I mean, if you think about it, I shouldn't be trying to write to the texture outside of the screen anyway. So I definitely should be clamping the bounding box. Okay, so now we can see hitches, but we can see what's causing them. And it's these particles that go entirely across the screen. And I don't think that's because they have really high velocity. I think it's because of some kind of error that's happening. Because we're clamping the actual velocity. It's not like I don't think it's a wraparound because I don't think the values will be big enough. Just to be sure, I'm gonna make the near clip plane like negative 795 z, so that we cut off the first 5 units of z. Okay, it's not fixing it. I'm not sure what values would be causing that, like crossing the whole screen. It's really funny how spiky my frame times are though, like it goes up to 96 milliseconds. Yeah, I tried adding near clip plane to cut out the close to camera stuff. Let me see if pushing it further away fixes that. Yeah, I think it's something else because let's try just really pushing it far away. Yeah, it's still happening. And you know what? Okay, so the problem is I'm clamping my world space velocities. I need to be clamping my screen space velocities. So yeah, let's stop clamping this. and instead compute the screen space previous position, and then let's clamp its distance from position 2D. So let's say so now I'm clamping the distance of the previous pixel in screen space. And that should actually fix the problem. Yeah, okay, that fixes it. So I think it probably was either stuff that was just moving so quickly or it was so close to the screen. And just to make sure my clip plane is actually working, I'm going to place it at 0, which should cut out half the particles. Yeah. You know what? I think my clip plane is on... It's not on the transformed position, so it was never doing anything in the first place. Let me make this projection thing return a full 3-dimensional vector. So it'll be z divided, and then I'll keep the z in. And now I can have center. Now I can use transformed z as the near clip plane. Vec 3 to Vec 2, line 23. Yeah, okay. '25. There we go. So now I have a clip plane at 0, and I think a bunch of stuff is disappearing like we would expect. So now let me make my near clip plane be negative 750 like I had before. Yeah, and now one more thing. Let's try no longer clipping our screen space velocity. And yeah, the worst of it is gone, so it was indeed just very close particles, so that a small velocity resulted in a very big screen space velocity. And like, this is not blowing up at all. Like, our frame times are just fine on this. It's staying around like 30 microseconds. I guess the frame times are a bit spiky. They're going up and down like by a factor of 2, but that's much better than like going up to 96 milliseconds. I think it's... Oh yeah, one more thing. I do need to weight down the opacity by the velocity. I think that will look more correct. So, yeah, let me take my velocity. So at velocity 0, opacity should be 1. So velocity is going to be screen space distance along the line. And if this is 0, our opacity should be 1. So basically we should divide by this. Where it's, if this is 0, we divide by 1. If this is 2, we divide by 2. So yeah, let's just do max 1 this, and then divide by it. That looks pretty cool. So let me revisit my coverage calculation. So when the pixel center is radius distance from the line, then my coverage value should be 0.5. So that means when it's half radius, it's 1. This should be 2, yeah. I had that wrong. But my coverage boxes are not big enough now, for some reason. So I might be doing it wrong. Okay. Now the coverage box at least matches it now. Let me try increasing radius to 2. Let's see like what 1.5 looks like. I'm going to try throwing a smooth step on so it's not just a linear fall off. I always forget the argument order of smooth step because it's like opposite from clamp. Probably looks better. I don't see a huge difference. Okay, let me crank it up to like 5. See how it looks. Kind of cool. Oh, you know what? I'm doing something wrong here. It should not be divided by radius at all. That's my problem. It should be... I have my distance, and it should be distance minus radius. And so now it's... And then it should be plus 0.5. So that when distance is equal to radius, it's 0.5. When distance is greater than radius... Yeah, that's correct. And then we clamp it to 0, 1 and do 1 minus. That's what it should look like. Now these will actually be like flat disks. I think I'm doing my bounding box measurement wrong, but that is much more like what it's supposed to look like. Oh, and again, I think I'm doing my velocity calculation for the coverage multiplier wrong. Let me bring radius back down to 2 and see what it looks like. Probably look better. That's cooler, yeah. Once they're big, I should probably shrink them based on distance to the camera. I think I need to enlarge the box by 0.5 in either direction. And potentially 1.5 because I think I need to round it up on the lower right. I think that's, yeah, okay, here we go. This is what it was supposed to look like with these circles. I'm going to quick take out the velocity divide. And see what it looks like. Okay, so I think it should be, if I'm clamping the velocity, well, I'm actually not clamping it right now. This will probably look better. Okay, I'm going to take particle size back down to 1. I think it might need to be something other than like a linear thing like this. Let me think through this. So like if it's smeared across 3 pixels, then the average value should be 1/3. So it seems like this should be making sense. Yeah, velocity of 2 plus 1 gives you 3. Divide by 3. And I have my sRGB frame buffer, so this is meaning I am working in linear. Let me try disabling this and see what it looks like. Even worse, frankly, for the velocity fading. Let me just take a square root of this for no reason, see if it looks better. Fall off is not very visible anymore, so I'm just going to leave it. Let me try 0.5 radius. I still think that's prettiest, but I maybe should try enlarging and shrinking them by distance to the camera. Before that, I'm going to try depth of field. Okay, so now that I basically have motion blur working like I wanted. I don't even have to clamp, but it's not blowing up anymore. So now I can try doing depth of field, which is where basically I need to go over the math again for this. So conceptually, depth of field, like the easy, cheap way I can do it is just by taking distance from a arbitrary focus plane I decide and enlarge the radius based on that. So I'm just going to do that for now. I don't think it's linear. I think it's like, you know what, actually I do think it's probably linear. So yeah, I'm just gonna make that guess that it's linear, and then later I'm gonna look up the actual math for depth of field. Okay, so our z value is, we're gonna say that the focal plane is at 0. So our radius is going to be enlarged by absolute value of our positions z, transformed position z. much, much, much too big. Divide this by 800. Well, 400. Let's make it go so that right at the camera near plane, it's going to be like 4 pixels wide. So that means I should do like, multiply this by 4. See what happens. Okay, that looks comical. It's too big. Plus I need to be fading them out based on that too. Let me see if this fades them out properly. They're still like silly big because I did my math wrong. So when they're at the camera, the z value has an absolute value of 750 is my near plane. I can't even tell if those are really distant. No, they're disappearing at the near plane, so they're really close. In my brain, this would linear in some kind of ratio. Yeah, I need to think about what it actually should be. In any case, this is only supposed to be 4 pixels wide at the camera. Like my center z is 0. So, and the camera is conceptually at negative 800. Wait, this returns... Yeah, okay. I'm adding 800 here, so I need to subtract it again. And then, okay, let me turn this down because it's a little ridiculous. And yeah, I think that it is not correct bokeh at all. Also, it's starting to slow down because of how big these get, so I should just clamp it. One more thing is I think I should have a distance fall off for these. So I'm just gonna do like basic exponential fog to fade them out. So wait, you know what? My near clip plane should be at like 50 for it to actually be working. No, I had that wrong. Oh yeah, okay, so here's the thing. My focal plane is at 800, so I need to subtract by 800. But my near plane is at negative 750. So that was my near clip plane thing is correct. Oh yeah, so distance fade, fog. Doesn't look like they're really fading. Okay, so again, transformed.z is 0 is at the camera. So let's try a much less drastic fall off. It's hard to tell. It would be easier to tell what's going on if the fog actually colored things, but like I can't really change the color because, like I said, this is additive. I mean, I guess it'd be possible to change the color, and I could still just treat it as additive. I feel like these just look really weird, all of these bokeh. Of stuff that's nearby. Let me push the near clip plane further out. Let me put it at 0 so I can see only the stuff that is further away. Okay, so yeah, those bokeh are distant, I can tell. So why are they not fading out more? Oh, yeah. I'm dividing by I need to be multiplying by this. Dumb. I'm making them do the opposite of fading out as they go into the distance. Let's make the near clip thing something insane again. Okay, now like the distant bokeh fade out, like they're supposed to. Let me make this even slower. Even slower. I think they need to be enlarging more quickly as they get close to the screen. If I were doing actual real. Math with this. Light makes a cone from the aperture to where it's focused. Yeah. Let me just look up. I do think it should be clamped to the radius of the circle of confusion, which I am clamping it. Let's have like a really narrow depth of field here. Make it a little bigger. That is actually starting to look a lot better. But I think it would look even better if I figured out the correct fall off for it. Okay, this will tell me. So given the depth value and the focus distance, yeah, they're doing it linearly like this, like me. Yeah, I feel like linear is probably okay. But yeah, let me focus on the center of the cloud. I feel like it's not quite right. Well, it's linear, but I think it's clamped. Like, you can't have a bigger bokeh than your aperture, right? Anyway, I'm gonna have to go read up on. I just kind of jumped into this. I need to go read up on actual depth of field stuff. Because the only time I've implemented this before was in a path tracer where, like, you can just kind of do a naive geometric thing, like pick a point on the circle of confusion and then trace a ray through it. That's looking pretty good, I think. Again, it's kind of limited by just the fact that it's single color. And also the fact that the shapes are not changing radius by their actual distance, so I don't have actual perspective either. So maybe I should do that, and then it'll start to make more sense. Okay, I think that I have to have, in my anti-aliasing, I need to have a flat values within the actual radius of the particle, and then the circle of confusion, it needs to have like a linear fall off within that. So let me just set radius to 0.5 and then have, or 1.0, and then I'm going to have my circle of confusion be I think that looks better. Let's turn up the effect. That doesn't look right at all. Okay, so I need to enlarge my footprint by both radius and circle of confusion now. I think that looks better. Now let me just change where my focal plane is. Let me switch back to radius of 0.5. Okay, let me check this thing. So like a different linear relationship in both directions. That seems plausible to me. But yeah, I'm not gonna bother to try to get it right now. I'm gonna go read something about it. See if I can figure it out. Okay, so why is my actual radius? Like it always looks the same. The bokeh are not actually increasing the size. My brain is not at full speed today, so I might have to kind of just call it good for now and then come back to it next time. I mean, I have something working. I got motion blur working, and then I have something like depth of field that is like subtly wrong. I haven't figured out the exact reason why. Okay, I think the bokeh is supposed to be flatter looking than that. But that looks okay to me. Okay, I think I'm gonna, after this last test, probably call it quits for today. I'll come back with fresh eyes sometime and try to figure out what exactly I'm doing wrong with the bokeh. I'm gonna try one more thing. I think that looks better, yeah. Wait, I'm already adding one to velocity up here. Yeah, so this was already correct. No, you're being helpful. Yeah, I just am not thinking clearly enough right now to be able to figure out what I'm doing wrong. I'm just gonna try doing that hack. Nah, I don't think it would help. I just want to get one pretty picture that I think actually looks right. too big. Looks kind of cool. Alright, I'm gonna go actually read up on how depth of field works. Come back and do it right. Make it prettier. Anyway, thanks everybody for tuning in. I'll be doing this again same time next week. And I will see you guys later. To have Hubble on the stream, so if anybody's still watching, can't finish the stream without Hubble, so. Okay. Here we go. Say hi. Slinky dog. Alright. This is Hubble signing off.